Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining OSPF route filtering within an area. Now this video is about a route filtering trick. What do I mean? Well, because OSPF is a link state routing protocol, route filtering can only take place at the ABR or the ASBR. For example, the filtering of this route here can only take place on R1, which is an ASBR, which is the router that redistributes routes from external sources. And filtering of this route here can only take place on R2, an ABR, which is a router between different areas. You can't simply filter one route within Area 0 from entering the link state database of only one router. For example, you can't filter this route here such that it is not learned by R4, because by definition, for link state routing protocols like OSPF, routers in the same area must have an identical link state database or LSDB. So you can't create a route map and apply it to an outgoing or incoming OSPF update and remove or filter a route like you would do with EIGRP or with BGP, because then the LSDBs within that area would differ from one router to another, and OSPF would break. We saw all of this very clearly in the previous video in this playlist. So this can be limiting, especially if you have a large OSPF area and you want to have more granular control over what routes a particular router will learn about and what you don't want them to learn about. Now, there is a trick that we can use to get around this behavior. Within an OSPF area, we can't filter what enters the local LSDB of a router, but we can filter what actually gets into the routing table. And we can do that using what is known as a distribute list. Now let's take a look at this topology here, and we'll be focusing on Area 0. Specifically, we'll have R3 advertise this network to R4 using OSPF, and we'll use a distribute list in R4 to prevent that route, which will appear in the LSDB, from being installed in the local routing table. So let's take a look at the OSPF configuration that has already been configured on R3 and R4. In R3, we can see that this network between the two routers is included in OSPF. This will ensure that R3 and R4 become neighbors. We also see that the 20.1.1.0/24 network on this loopback interface here is also being advertised in OSPF. I've also explicitly configured the router ID of R3 to be 3.3.3.3, and we'll be using that shortly in our verification. On R4, we see the network of this link is included in OSPF, so the neighbor adjacency should come up across this link. So with this setup, the 20.1.1.0/24 network will be advertised to R4 using a type 1 LSA, because both R3 and R4 are in the same area. This is an intra-area LSA, and due to the requirements of OSPF to have an identical LSDB on all routers within an area, type 1 LSAs cannot be filtered. Let's go into R4 and see what we see. If we look at the routing table, the 20.1.1.0/24 network has been added with the appropriate next hop address and exit interface. This is as expected. Since we see it in the routing table and it is an O-type route, we know that this route exists in the LSDB as a type 1 LSA. Now let's try to filter it out of the routing table. We start off by creating an access list that will match the specific route we want to filter out. ACLs are often used to match traffic, and then they are referenced by other entities to use them for that purpose. Our distribute list will use this ACL to filter the specific routes. So we put in this command to deny the specific 20.1.1.0/24 network. An ACL always has an implicit deny any statement at the end. So we have to add this permit any statement, otherwise our ACL will block everything. And we just want to filter out this specific route. So once our ACL is created to deny the specific route, we then go into our OSPF configuration and issue the command here. This creates a distribute list that will use the ACL to filter OSPF updates in an incoming direction. So where is this distribute list actually applied? We can imagine that it acts upon the information sent from the LSDB to the routing table. For this reason, you would always use it in an inbound direction for this kind of filtering. Now let's see the results. You can see here that the specific route is no longer in the routing table. That's what our goal was, and it looks like we've succeeded. Let's take a look at the LSDB, however. By issuing this command here, we are asking to look at the LSDB and specifically at the LSAs that were received from the router with a router ID of 3.3.3.3, which is our R3 router. We can see that the 20.1.1.0 network does indeed appear as a type 1 LSA, or a router link state as it is called in this output. So the route is still in the LSDB, but it simply is not installed in the routing table. Now, one last thing I would like to share with you. This feature should be used carefully because it is easy to black hole traffic if misconfigured. For example, if we add another router to the topology, R5 in this case, like R4, it will learn about the 20.1.1.0/24 network via OSPF. So the LSDB of all these routers will be the same. R5 will install that route in its routing table and will have R4 as the next hop for it. Now, if R4 does not have this network in its routing table due to our distribute list, when R5 tries to reach it, it will send all its packets to R4, and R4 will drop them because it has no entry in the routing table to serve those packets, resulting in a black hole. So make sure that this feature is used with care so that such a scenario does not occur. Well, I hope you found this video useful, and if you have, I would ask that you consider using the YouTube Super Thanks feature to say thank you and support my effort to simply explain telecom and networking. As I'm always striving to improve my videos, the funds will be used to support better equipment, better quality, better video editing services, and just to produce more useful training content. As always, check out my website where you'll find in-depth courses with labs, quizzes, and exams to test your knowledge and prepare you for certifications, as well as for the real-world networking and telecom industry. And don't forget to subscribe to the channel to get updates to newly published videos. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.